Hi, welcome. This is my title, it's quite a mouthful. It's called A Whirlwind Tour Through Lingual, ANSI SQL for Apache Hadoop. But before we go in, I would like to understand who of you that is in the audience has done anything with Hadoop? Please raise your hand. Okay, that's good. Has anyone ever done anything with cascading? Ah, sweet. And who of you has ever done anything with SQL or SQL or however you pronounce that? All right. Okay, so before I go into the... oh, I'm on the wrong screen. That's, of course, a problem. Like that. Quickly, a word about me. I'm André. I work for a company called Concurrent Inc. We are based in San Francisco, and we are the makers of Cascading and Lingual. Lingual is the thing that is on the front page of the slide deck, but Cascading is the foundation to make Lingual. Both of them are open source projects, and yeah, well, we make those, but there's a community around them. We sponsor development on those open source projects, but there's community contributions, so it's good fun, join it. I can be reached on this email address if you want to, or you can tweet me. I like that a lot, so if you want to follow me on Twitter, please do so. If you want to say anything about my talk, use the hashtag Lingual. That would be very nice. But without further ado, let's take a look what we want to do today. The first thing we want to do is look at our agenda. I have 5 blocks, in which my talk has 5 blocks. The first one is building up a bit of context in terms of what is cascading and what is Lingual, how they relate to each other. We need that understanding in order to go deeper into Lingual. Then I'm going to talk about Lingual, the design goals, which means what are the problems, what is the problem space we're in, what do we want to solve with Lingual. Then I'm going to talk a bit about the features, so how are we solving these problems in Lingual. And then we're actually going to do some Lingual in action. So I'm actually going to do real SQL on a real Hadoop cluster in front of all of you, so there's nothing prepared, it's not a video, it's real, it's the real thing that you're going to see. And then, of course, we have questions and answers. And I have to find my mouse again. This is a bit confusing for me, but okay. So Cascading. Cascading is an open source framework. It is Apache licensed. We are not part of the Apache Software Foundation, but we use the Apache software license, so it's free of use. You can use it in your applications. It is meant for building data-driven applications. Now, what does that mean? You have a lot of, like the talk before was about REST web services and these kind of things. That's not a data-driven application. A data-driven application is something where you have a humongous amount of data sitting on some sort of storage device, on some sort of back-end service or whatever, and you have to go through all this data, you have to crunch it, to munch it in order to answer a business question. Your business has questions, and those answers might be in that data. And that is what Cascading is for. Cascading tries to make it easy for real-world developers with normal Java knowledge to write such applications. One of the things is like you start out writing an application like without any of those frameworks, and you end up having to do job scheduling, and you end up to have like data. You need to partition your data and all that stuff. That's not really what you want to do. You're paid to answer the questions that your company that you work for has. So you shouldn't be an expert on distributed systems. You shouldn't be an expert on how to configure HDFS and how to set up a job tracker and what Hadoop actually is. You should be writing business logic that answers the questions for your company. So that's what we do. That is what Cascading is all about. We are taking the bitterness out of Hadoop, let's say, and making it a bit more sweet, so you have a bit more of a nicer programming model. As you can see, there are a bunch of components, and at the very bottom, there's, on this slide, it says Apache Hadoop, but we also have another mode on which we can run, which means you can run on Hadoop, but we also have a local mode, and there might be other things in the future, meaning you write an application, a data-driven application that processes the data, and it can, in the future, maybe run on some other cluster technology seamlessly without you having to do anything. That's the goal. The founder of our project is called Chris Wenzel, and he started the project, I think, 5 years ago, because he saw that MapReduce is a great base technology for storing data and having a job scheduling framework, but it is hard for programmers to get started. Everybody that has ever written a MapReduce program and the data input format and the data output format and has fiddled with the millions of options in the Hadoop job conf knows that it's actually not fun to do that. It looks fun on the outside because it's all new stuff, but once you go into the details, it's not fun. Well, what's fun? Cascading is. Some terminology around cascading. So the base idea in cascading is that we have a pipes metaphor. Pipes are nice, and everybody knows pipes. Well, you know them from your plumbing in your bathroom or in your kitchen, but you also know them from Unix, right? Everybody has in their life somehow touched a Unix pipeline, where you have a producer that has data that is spit out and it's filtered through a series of other programs that then do something with the data. There might be aggregations happening, and there might be filtering or whatever. You know the deal. This is nothing new. But we take this metaphor and we give you a Java framework that does exactly that. So, but about the terminology, first of all, we have something that we call taps. A tap is either a source or a sink, which means this is where data is coming from, or this is where data is going to. Easy enough. Then we have an abstraction that we call schemes. A scheme is basically telling cascading about the structure of the data. What do I mean by structure? Suppose you have CSV. CSV has certain properties. If cascading has to read a CSV file, cascading needs to understand what that means. So you need to split on the comma, you need to do the quoting right and stuff like that. But it can be more sophisticated. It can be an Avro file where you need to read the schema and then present the data in a certain way, right? That's the scheme. And then, of course, we have the pipes. So the pipes are connecting the taps, and the data is flowing through the pipes. And then the next slide about the terminology. Through those pipes, we have a thing that flows through them, which is called tuples. And if you follow a few of the presentations here, you see this is kind of always the same. You have like data flowing through a system, which is represented in a very concise or very compact structure, and it's just pushed into the business logic that you implement. Instead of you looping over something, your code is executed on these tuples in a tuple stream. So that is what I mean with there's a thing called operations. That's actually what you write. So it's kind of like you apply a function to the data that is being streamed through cascading. So this is very, very different from the MapReduce programming model, where you have to write a mapper and a reducer, and then you have to invent tricks to make the keys appear on the reducer side correctly. Well, we do that internally, but you don't have to anymore. You just write, you say, here's my tap, here's my source, here's my sink, and now I want to do a count, or I don't know, I want to do an aggregation, stuff like that. That's what you do. And there's something that we call flows. So a flow is one or more, in the Hadoop world, it's one or more MapReduce job that gets scheduled on a cluster. So easy enough. So cascading takes whatever you program, looks at it, builds a physical plan, and executes that plan on a Hadoop cluster if it runs in Hadoop mode. If it runs in local mode, it does it locally. And potentially there will be new modes coming. One new thing that is coming along is right now Hadoop 2 support. Because Hadoop 1 and Hadoop 2 are slightly different. It's not just Java. It's, first of all, cascading itself is written in Java, and it's geared towards Java developers, and especially geared towards Java developers that aren't distributed systems expert, but like normal programmers like you and I. But not everybody likes Java these days. So there's also like the hip, cool new languages that are covered. One is Scalding. Scalding is a DSL on top of cascading. It comes out of Twitter. Twitter actually, every revenue app that Twitter has, so everything that Twitter uses to make money goes through cascading, because they use Scalding, and that is, everything is cascading based. So you see, we are production ready. This stuff actually works. If you say, well, all this type magic in Scala isn't really my thing, then you might be interested in Cascalog, which is a Lispy thing. It's a closure DSL, which is inspired by something called Datalog, and is by the same guy that invented the Lambda architecture term that Nathan presented earlier on. So those things exist. This is cascading. And now we want to give you a new DSL. Well, DSL is maybe the wrong word because it's not really a domain-specific language. SQL or SQL is a general-purpose query language. And this is something that we want to give into the hands of developers so that they can use the power of cascading without needing to know any Java or Scala or Clojure or any of these things, by only knowing SQL. We basically have three big design goals. When Lingual was initially designed, there were three big design goals which are important to understand. The first one is immediate data access. So you might be working in a big organization, or you might be doing consulting in a big organization, and now the developers needed the cool new stuff, and they bought a Hadoop cluster, and now it's sitting there, and there's tons of data on that cluster, and now there's somebody else in your organization that actually wants to access that data, and you tell them, well, you can submit a ticket, and maybe you write your MapReduce program, and then you can come back in half a year. Well, that's not really nice, right? You want to give people the possibility to query that data that sits on the Hadoop cluster. Some stuff is aggregating there. People want to do something with it. The business needs to answer questions. So what we give you is a JDBC driver that you can put into any JDBC-aware application, and you can query the data that sits on your Hadoop cluster. Also, we give you a little SQL shell, so you don't even have to install any of the UI tools. There's just a little shell which actually uses JDBC to talk to your Hadoop cluster. The next design goal is simplifying SQL migrations. What I mean with that is that people see their data is growing, so they are constantly adding more and more data, and their workloads becoming more and more complex, and their traditional ways of processing can't cope with it anymore. However, you have developed a lot of business logic in SQL. So you have these experts that sat down, and for over years and years, they have developed ANSI-compliant SQL statements that answer your business questions. So what do? You want to move these exact same SQL queries onto your Hadoop cluster, which they bought, and it's just sitting there idle. So you want to move those over. Plus, you might be adopting cascading and say, like, well, from now on, we're not going to do everything in SQL. We also move parts into cascading, but I still have this complex SQL query over here that I want to join with this, and you can just do that. So there's an API that helps you in combining a SQL-based workflow with cascading. So you can munch the two together, and boom, you have a new application, and you can answer new questions. And then the third one, last but not least, is system and data integration, the simplification of that. What I mean with that is that a typical organization does not only have one data store. People buy Oracle clusters for some reason, and other people buy MySQL or not. People might deploy an HBase. They have a Hadoop cluster with HDFS, or people might be adopting Redshift from Amazon and stuff like that. So data is floating around everywhere. And now you have these highly trained people that can only speak SQL. Wouldn't it be nice if we could give them a way to speak SQL to all these systems that aren't really made for that, and then process all this data in one process on our Hadoop cluster, where we have the computing power and where we have the storage to do all of that? That would be kind of nice. So this is the third goal, and this is, but it's also very important, because if you look at typical business processes, somebody has a database over here, and somebody else has another database over there, and then somebody asks, can't you guys just put those two things together? Well, try to do that with normal SQL. If one is MySQL and the other one is Oracle, you can't really do that in an easy fashion. It's going to be getting very nasty. So that's something we try to solve. And now I'm lost. Yeah. Which brings us to this schematic overview, this overview of Lingual. At the bottom, we still have Apache Hadoop, but as I said earlier, since cascading also has a local mode, Lingual as well has a local mode. So it uses whatever cascading uses, right? Then we have cascading itself. So Lingual is actually a cascading application with, well, a very, very fancy cascading application in the end. That's what it is. And then we have two parts that are sitting on top. The first one on the left-hand side is the catalog. Well, one of the things we want to do is you have this data on your Hadoop cluster, and you want to query it with SQL. But we don't want you to have like complicated loading processes. You know how that goes. Somebody has like a bunch of files and they say like, I need to make this queryable, so you load it into a database. This process takes days or whatever. It depends on your data size. But we don't want to do that. We just want to give you immediate access. But what we need to be able to do that is a bit of metadata. We need to know what your data looks like. So you need to tell us, well, there's a file over there, and I'd like to access it as a database table. And you need to tell us, well, what are your columns and what are the data types? SQL is all about types, or a lot of it is about types. So you say you have a varchar, or you have an int, or you have a whatever it is, whatever you like. So you need to tell us what it is so we can treat it in the right way so that we can also do joins across these different systems which might have completely different type systems, right? Look at an HBase, and HBase has an amazing abstraction for data storage, which is byte arrays. So we need to know a way to kind of read that stuff back into meaningful Java structures. But if you would write, for instance, an HBase application, you know what you stick into it and you read it back. But we are a framework, so we can't know that. You need to tell us that. So we need to know a bit about the data that you have, right? That's maybe something I skipped over in the cascading slide. In cascading, we have something similar. In cascading, you tell us, we have tuples, and tuples you know from databases as well. That's the stuff that flows through cascading. And we have something called fields. And the fields is basically the similar concept to the catalog, where you say, well, these are the different fields in this tuple. And now we have optional types for those in cascading as well. So you can say, well, these are actually ints or these are strings. But the types are optional, so you can do very nice dynamic typing if that's necessary. Lingual, however, is SQL, so we need those types. So they are given via the catalog. Then we have, of course, a query planner. The query planner reads SQL and turns it into cascading operations, one way or the other, right? And then on top of that, we have 3 blocks. The middle one is the JDBC API, so we have a full-blown JDBC driver that works. We have a cascading API. As I said, if you have the SQL and you want to turn it into a cascading application, you copy and paste the SQL into a little bit of Java code, you build your Hadoop jar, you're done. And then the last one is the provider API, which gives you access to third-party formats or storage mechanisms. So it's not just all about talking to different systems that are something else, like talking to HBase or talking to Cassandra or talking to whatever. It's also about what is the format on disk, because as Nathan also rightfully said, you might not want to use CSV on Hadoop because it's not a very efficient storage format. You might have a thrift file or a protobuf file or something. So you can also tell us, there you tell us about the types and how your data looks like. One very important thing is as Hadoop is about batch processing, and so are cascading and lingual. So we say we make SQL, but this is not for building CRUD layers. That doesn't make any sense. Because what are we doing in the background? We're actually submitting Hadoop jobs. And just the Hadoop just transferring the jar file over to the cluster and starting a Hadoop job takes so much time that you can't really satisfy any meaningful interactive app with it. That being said, that's also not the goal. Our goal is saying, well, I have 50 petabytes of data running around, and I have the SQL expert. How do I get them to answer my questions? That's what we want to do. Well, I mean, if you have 50 petabytes, you might have other problems as well. But you get the idea. It's about batch. It's about processing large amounts of data. Cool so far? Everybody with me? That's great. So I've shown you what is cascading. I've shown you what are the 3 design goals, and I've shown you a bit the parts of the system. And now let's actually do some lingual and switch to demo mode, which I like more than slides, because it's a bit more interactive, and we can have some fun. So what I have here is just a Unix shell. Can you read this? Is this big enough? Want to make it bigger, smaller? Comic Sans Serif or something? Okay. All right. So what I have on my machine, well, this is my machine, but I'm going to log into a real Hadoop cluster that I have deployed on my laptop. So who of you uses Vagrant? Who's a fan of Vagrant? Yeah, great. Vagrant is an amazing tool. Well, Docker is now getting more of the press, but Vagrant is great because it's portable. Well, what we have in the Cascading project, we have an Apache Hadoop cluster that consists out of 4 VMs. that you can just deploy on your laptop. So you type 3 commands and you have a fully distributed Hadoop cluster running on your laptop in more or less 15 minutes, depending on the download speed that you have towards the public internet. That's pretty nice. So you just type Vagrant up, the whole thing boots up 4 machines, and you have a name node, and you have a job tracker, and you can do real-world Hadoop with it. So to show you that that I'm not lying, I can show you, first of all, so there is the name node. So we have a HDFS, distributed file system. We can browse this. You see there's a user directory, but it's empty, so it's a pretty pristine Hadoop cluster that we have here. Well, in brackets, this is of course not a real-world cluster because my laptop isn't that powerful. It's just meant to have a real distributed system, because that's then nice if you want to debug something. Running in real distributed mode helps you finding a few problems that you can't find in a local mode of Hadoop. And of course we have, this is HDFS, I'm sorry, and we have also the job tracker. So the job tracker is for the people that don't know Hadoop. This is where you can see the current jobs that are running on your Hadoop cluster. So we have these 2 things, and I'm now going to log into the master node. Hopefully, yeah. So I'm going to a master node, and I'm on it. So this is just a Linux VM, and on this Linux VM, the very first thing I'm going to do is I'm going to set the platform. This is an environment variable that I set to tell Lingual you're running on Hadoop. Because it has 2 different modes, you have to give the mode flag, and in order to save some typing, I'm just setting this environment variable, right? That helps me remembering doing all the things right while I show you this stuff. So Lingual comes in different shapes. You can get it, you can download it from the website. If you use it as a library, we have a Maven repository where you can pull stuff down from, and this cluster actually ships with the Cascading SDK. The SDK is a collection of tools and tutorials and code and all the good stuff around cascading. So it contains cascading and Cascalog and scalding, and it contains Lingual as well. So Lingual is installed on this thing, and it's a shell script in the end. In the end, everything is a shell script. You know that, right? The world is tied together with shell scripts. And it comes with basically 2 commands that we want to look at. The first one is the shell, and the second one is the catalog. Let's just start it right up. So let's take a look at that. So this is it. It's very fancy user interface that we made for you. No, this is actually SQL running on top of our JDBC driver. So as I said, we just have a JDBC driver, and this uses it. So this is there's no special code in here. It is a SQL shell that uses our JDBC driver to do stuff. Now we want to know what kind of stuff is in our cluster, so we say something like bang tables. Bang tables is a special command to show us the tables that are currently registered in our system, and because this is a completely pristine, has never been used, this system, it's of course empty. So let's change that. Let's change that, yes, now. And therefore we have a demo data set. So if you follow the Lingual user guide, all this stuff is also in the Lingual user guide. So if you want to take a closer look at all these things, you can find it there. So I have a little directory which is called employees. And in this employees directory, I have a bunch of, a set, I shouldn't say bunch so often, a set of CSV files. So if I look into this thing, we have a bunch, or let's do this. So you see there's a bunch of files, and there's, for instance, a titled CSV that looks like that. So we have employees, titled CSV. So you see there's apparently a number, and then there's a title, I guess, and there are 2 date fields. Note that there is no type information in these CSV files. They don't come with a header, so we don't know. Okay? So far you're with me. This is just files on my local disk. Now, let's get that onto our HDFS, onto our cluster. So we do a Hadoop fs -copy from local. Employees. So we take this stuff, move it from our local disk onto our Hadoop cluster. Well, if you have a big organization, this might be a log collector that runs on your web server that pushes this stuff to your Hadoop cluster every night, but this is just a simple demo. So to show you what this does, we can go back to our file system. So we go back to the user directory. We now have a user Vagrant because I'm logged in as Vagrant, and the employees are here. So we can now take a look at this title CSV file again, and you see the data is on Hadoop. So we have now test data on HDFS, and we want to do SQL with it, okay? So we're going to skip the catalog for now. We're just going to do some SQL. So in order to, but we need to still register the tables. So we have this little shell script, and we look at the catalog after this, but I want to go for SQL first. I want to do your and O first before we're going to do the boring catalog. So we're going to run bash create employees, and this is going to initialize the catalog and registering all these CSV files that we just saw in Lingual. So you see it creates apparently a schema, which is called employees, it's scoring by, and it's registering the different tables. Now, since this is HDFS, those files could be really humongous. The test data isn't, of course, that because it needs to finish in time while I'm doing my demo, but they could be very big. So once this is done, okay, so we now have this, and now we can go back into Lingual, and we can say Lingual shell, and we can say bang tables again, and we see we have now a bunch of tables registered, okay? Now let's look at one of those tables and say bang columns, give the schema, which is employees. I'm also the world's worst typist. That's very important to know. So this, and then we see, okay, there is apparently a field employee number, which is the number we saw before. There is a title, and there's a from date and a to date. So then next to that, there are data types. So you first of all see the data type column. Those are actually the JDBC data types. If you look at the JDBC metadata API, you see those types. So we need to expose those, obviously, because we're speaking JDBC. And then we have our internal types. So the first one is int. Then we have, you can't see that. It's actually, at the very end, it says Java lang string, because it's a string. We don't do the varchar. We map strings. We map varchar to strings. And then to date objects. We also support timestamps and date time objects and those kind of things. Okay? And now we can do some SQL. So we could say select star from employees dot titles. Okay? That's it. So I just issued a SQL query. It was taken by this JDBC driver, given to Lingual, to the cascading part of Lingual, analyzed, and it read the data back and transferred it back to us. This query didn't start any Hadoop jobs at all. Why is that? Because we didn't filter anything. Lingual is smart enough that if you just do a select from, it just pops open the file and streams the data back to you, because there's no necessity to do any streaming. It knows like, hey, my data lives there, I just give it back to you. That's an optimization that makes these kind of things very fast. Now, as anyone that is learning about a data set, what we do is, or what you would do is like, oh, I want to understand what sort of titles are available in this little company example that we are having in our employees data set. So I'm just going to run a select distinct query, and this one is actually going to start Hadoop jobs. So we can do F5 here, and tada, there is a running Hadoop job. It has the typical, well, we have the typical overview. We have 2 map tasks that are currently running, and you see they are, the first mapper runs on the first part of the titles file, and the second runs on the second part of the titles file. And then we also have, once this is done, well, the mappers are done, now we have one reducer that is running, so it's just right now doing the copy operations, and it's done. So if we go back to our shell, we have our answer here. So what right now happened is, we took SQL, we analyzed, we saw there is some filtering, no, there's some aggregation, or, well, Is it aggregation? Well, we wanted to know the distinct titles that are in the thing. So we know, okay, this is an operation that we need to do on this file. We issue a Hadoop job and stream the result back to us. Now, sometimes you're running jobs that don't take 33 seconds. They run like 18 hours or something. And then it scrolls by and it's gone. Therefore, we also have something, we have a special schema which is results. So we keep the last results around. They are streamed onto HDFS so that you can get back to them. And to show you what they look like, back here, there's actually now a results directory, and you see there's the part 00 because we had one reducer, like normally in Hadoop, and our content is in there. So you can reuse this. This is also automatically, again, registered as a Lingual table, so you can keep on redoing that, because that's also a typical thing that you find in many REPLs, if you do like Python, or I believe Ruby has that as well, where like the last result is sort of stored. Similar concept here, right? So that is all nice and shiny, and then we might be interested in saying like, well, how many people are actually having the title engineer in this little company? Well, what we're doing here now, we're doing filtering, because we go to the titles table again, and we're doing a count operation. So there are mappers running. What are the mappers are going to do? They're going to emit every record in the titles that has an engineer, and then in the end it goes to a reducer and is going to do the count. Easy enough, right? So if we go to our job tracker again, see, it's running here. Now imagine, this is of course a very small data set. Imagine this would be a lot of data. Imagine what Nathan said earlier on. I don't know if you saw his presentation, but you have your batch layer and you want to extract values that you want to write to somewhere. Well, this is exactly it, but you can do it with SQL. Instead of writing a Java application or a cascading application or raw MapReduce, you can just do it with SQL. Anybody that is trained in SQL, which are, I think, more people than that are trained in Java, can do that. You typically have people that do your analysis in your company, and they're not Java programmers, they're SQL developers. That's at least how I know it. So this is apparently a very big organization. They have 115,000 engineers. But yeah, that's a good insight. Now, maybe your HR people want to know, what is our diversity? So diversity is important in companies, so we want to know, like, how is the ratio between male and female, ordered by looking at all the employees. Now, this is the next step. What we're going to do here, what we're doing here is we're doing a join. So we look at two files, we filter out by employee number, so we do the actual joining, and then we do a group by and we do an order by. This is an interesting little thing, because it will actually spawn multiple Hadoop jobs. My cluster is only capable of running one at a time, because it's running on my laptop, but if this would be not the case, well, you get the idea. So this is running, so there's the first map tasks have already finished, the reducer is running. Also, everybody that does Hadoop knows that you F5 a lot, if you're on this page, I guess. That's a common scheme, that you hit F5 quite a bit, if you're trying stuff out. So this has been done, and now a second job will be starting. Any second, there it is. And that actually takes input from the first MapReduce job that ran, takes that input and does something with it. That's also what cascading does. So if you are writing your data pipelines in cascading, it will not be like one map operation and one reduce. No, it can be like 30, 50, 100 of those chained after each other. But you don't see that, you don't need to know that, because cascading translates the things into the map and reduce operations for you. I believe we're done. So that's immediately the result. Clear so far? So, and now you can imagine we can do table subselects, we can do inner joins, we can do outer joins, full outer joins, the whole thing. So if you can write SQL, you now have access to your data on Hadoop. Except for when it's maybe not in the right format. And that's what we're going to look at next. So a concept in Lingual is, or the thing in Lingual catalog. It's the catalog. As I said, the catalog is a metadata store, and it is also the tool that you use to manipulate this data. Maybe I can quickly show you where this metadata lives, because this is something I haven't said yet, is that there's a .lingual directory, and here's your catalog. It's just a JSON document. So there is no infrastructure to be installed here. You don't need to install any sort of service in order to have a catalog. It's just a file on HDFS, which is very robust towards failures. You are not going to overload some sort of storage mechanism, some sort of central instance that you're talking to. You just have a file on disk, and it's just JSON. So you could even manipulate it if you wanted to, but we have the catalog tool to do that. Okay, so we could now say Lingual catalog, show me your formats. So formats are a thing which, like, what is Lingual capable of reading? What kind of formats does it understand out of the box? Those are the four that we have. We have CSV, TCSV, TSV, and TTSV. Those are very common formats, but they don't cover everything. But you can write your own format, which brings us to the provider API, which all this part of the talk is going towards to. So you can, by writing a little bit of Java code, tell Lingual about a new format. You could say, here is a fixed record sort of file. Here is a binary file, and Lingual will understand it. All you need to do is write a little bit of a factory class that we have. You don't even need to implement an interface. We find the correct method via reflection. So you're not bound to Lingual. You can just write a little format, and you can do SQL on that format if it lives on your HDFS. The next thing is protocols. Protocols are the way to get to the data. Well, this is Lingual running in Hadoop mode, so the protocol is HDFS, obviously. Okay? If it would be running in local mode, it wouldn't be HDFS, it would be local. Now, wouldn't it be cool if I could, like, talk to HBase or talk to Redshift here? Yes, and this is the other thing that you can do with a provider. You can say, like, not only can I tell you about this other format, I can also tell you how to get this data from a completely different system. And this is what we're going to do. We're going to install a provider, which I pre-downloaded. Usually, I would download this from Maven repository, but I don't trust the network here too much, so I pre-downloaded this. All this is a jar file. This jar file contains some code. It's actually, it's important, it's a fat jar. So everything is packed into it, because we're going to submit this jar onto the Hadoop cluster, and therefore it must be a fat jar. And it contains one little file, which is a properties file, in order for so that Lingual can find where the formats and the protocols are defined. And this is actually an interesting little provider, because it makes Lingual capable of talking to remote Derby servers. So we have a project called Cascading JDBC, which abstracts JDBC databases to make Cascading capable of talking to JDBC. So we have something for MySQL, for Postgres, for Derby, for H2, and even for Oracle. That one you have to build yourself, because we can't redistribute the Oracle JDBC driver, but it's there. So you can talk from Cascading to Oracle, but you can also talk from Lingual to all these systems. All you have to do is install a provider. And that's pretty simple. Let's just do that. It looks like this. Where am I here? So just say catalog provider at and point it to the local jar file. I could have given it Maven coordinates, and it would go out to conjars.org, which is our Maven open source Maven repository where you can download these things. It would have downloaded it and found it automatically. Again, didn't want to do the network thing. That was too risky. So that's why it's a local one. And now if we look back at the protocols that Lingual speaks now, we all of a sudden have a new protocol. We have a JDBC protocol. So Lingual can now talk. It's a bit awkward because you have two layers of JDBC, but that's the beauty of it. You can build systems like that. And in the real world, people have structures like that. So this is why we made that. And if we look at our format again, we also have now Derby as one of the formats that it supports. So this provider gave us a new format and a new protocol. Okay? A provider could also only give you a format or only a protocol. You could say, I can read CSV files from a web service. Not that that is maybe a good idea, but it's possible. So then you would only implement a protocol, but not a format, because that's already in the system. Okay, and now we have this provider, and let's do something with it. So what I'm going to do here is I'm going to use the catalog tool to define a new schema with one table in it. And this table will not be on HDFS. This table will be on a remote Derby server, and we will transparently write into this Derby server without writing any line of Java code. So what I'm going to do is I'm going to make a select query that goes in the CSV files on our Hadoop cluster, does the computation there, and writes it into Derby. Now, coming back to Nathan's talk, this is actually exactly what the batch layer is all about. You're looking at your humongous data set, you're doing the computation, and you're writing it into your view. And the view is, in this case, a Derby database. It could be MySQL, it could be HBase, it could be anything. All you need to do is having a provider. We are making providers for JDBC, we're having one for HBase, Redshift is also in the making, and we also welcome contributions from the community. So if your data storage isn't supported, well, let's talk, let's see how we can do that. So first thing we're going to do is we need a new schema. So we're going to add a schema which we call working. Okay? Easy peasy. So this has now gone to the JSON file on HDFS and added that schema. The next thing we're going to do is we're going to define a stereotype. Now, stereotypes are something that I haven't talked about yet. But stereotypes are basically, this is where Lingual learns about the data types and the fields in the data you're going to read and write. So think of our titles, CSV file again. There were 4 columns in there. There was a number, which was an int. There was a string with the title and 2 dates, from date and to date. Well, this is exactly the same. We're going to define a stereotype called titles, and it has 2 columns, which you see here at the very far. One is called title, and the other one is called CNT. So we're going to count titles. Didn't call it count because that's a SQL keyword, and that is a bit problematic using those. And they are of the types string and int. That's what I tell Lingual, so that Lingual knows what is it that I'm talking to on the other side. Are these types actually compatible? Do I need to do something with that, or is it even working if I write into this or read from that? Because SQL is about types. Okay, so we have now this stereotype. And now we need to do a few magic things in order to make Derby happy. This is highly specific to the Derby provider or to the JDBC provider itself, because we're talking to an empty database server on the other end, but we want to write into the table. So the thing can actually create the remote table for us automatically. But in order to do that, we need to tell it what is actually the table structure you want to create. If you would be using HBase or Cassandra or something, that looks completely different. The properties you're giving here are completely different. If you have an HBase, you would say, what is my column family I want to write to? What are my qualifiers I want to write to? Or if you use, for instance, Redshift, in Redshift you have like this copy operation where you copy data from S3 into the final Redshift instance. You can give a timeout. So this would be properties that you can give that are format and protocol specific. And because this is JDBC or RDBMS, we need to give it a bit of meta information so that Lingual can satisfy that. Okay? And now the big, ugly command line comes, which looks like this. So what I'm saying here is, dear catalog, in the schema working for the protocol JDBC, which is coming from the Derby provider, add the following property. So I'm saying I want to create a remote table called title counts, and it has this table description. So this is the varchar and the int on the other end of the table, and I'm saying please do it with the Derby provider. I give the provider here because I could have many JDBC providers in my system, but I want to specifically do it for the Derby provider. If I had MySQL and Oracle and Postgres all at the same time, well, Lingual needs to understand and differentiate. And then last but not least, what we then do is this. This might all look a bit overwhelming, but it's actually quite simple because, come on. What did I do now? This. What I'm going to do now is the final step where I am going to register the final table. So I'm now telling Lingual, there's going to be a table title counts, which is in our schema working, and it is using the stereotypes that I introduced. So I'm telling Lingual, these are the types that are going to be in my table, and you can find this table actually at this address. And this address is in this case a JDBC URL. In the other example, that is an HDFS URL. This is the protocol we talked about. So I'm just saying, hey, make this Lingual table. It's called this, it uses this stereotype, and it's backed by this. And that could be anything. And these things are swappable. Now, I'm adding this. And it's done. So that's were five steps, not really complex. And what I can now do is the following. So first of all, we do bang tables again. We see that our working schema has appeared in the third from the bottom. And we have our title counts table in there. And it just looks like any table in the system. And what I can do now is the following. Where is my mouse? There it is. So I'm going to execute a query which is insert into working title, select title count title as CNT from employees titles group by title. What does it do? It goes into the titles table, which sits on HDFS, does all the calculation on the Hadoop cluster, and transparently writes the result into the remote Derby table. So let's fire that off. So nothing special from a Hadoop perspective, because it's just mappers and reducers again. Mappers are starting, so the mappers are now crawling through the titles table, and then there's going to be a reducer that does the count, and in the very end, everything is streamed over to a Derby database. Now, imagine this would be your Oracle cluster, or your Postgres, or your whatever you have. You can seamlessly do computations with data coming from different sources in one SQL query. So what I'm capable of doing now is saying, hey, I have this HBase table, and I have this Derby table, and I have this file on HDFS, and also this Redshift thing over here, and I want to merge them all together, and I want to answer a business question with that, without writing any line of Java code, by just doing SQL. And this is what we can do. Will this be super performant? Well, of course not. Will this be very useful? I think so. Why will... So this is our result. Why did we not get any results? Because we wrote to a remote system. We didn't stream the data back to us. We actually wrote to the remote Derby server, so we only get the row count back. What we got back is like, okay, there's 7 different titles within the system, and we counted them, and they have been written to a remote Derby table that can now be used by some other system that is in there. But because this is read and write, we can actually do something like that. We can say select star from working title counts. And boom, What this did is actually talking to the remote database and streaming it back to us, again, seamlessly. 12 minutes left. I'd say this is all I got so far. I have this schematic overview again so that you see the things I talked about. What I showed you, have shown you is the provider API, the JDBC API because we are using the SQL shell, and but I didn't show you the Cascading API because I deliberately wanted to show only SQL in this slide, in this talk, so that you understand that if you have people in your organization that can talk SQL or can write SQL to answer questions, this is what they want to use. And now I'd like to take some questions, if any, and there's also a link collection in case you are interested in Lingual or Cascading or any of the other stuff we're doing, or a company website, and so on and so forth. So thank you, and if there are any questions, please ask away. Yes?
Is it possible to write some UDFs as well for Lingual?
The question is, is it possible to write UDFs? The answer is right now, no. Since we envision that you would do a SQL migration in the end, you can write something in Cascading then. But there is no such thing as you would have a UDF that you deploy. No, that doesn't exist. No. There was another question? Yes, up there.
We mainly use Hive for our work. How would you compare Lingual to Apache Hive?
How would I compare Lingual to Apache Hive? Well, they're quite similar indeed. Yes, but we are ANSI SQL compliant. That is our big thing. That's what we say. Which is important. We want to really be able to copy and paste the queries that are there. Plus, we want to be able to combine things with cascading, right? So since Lingual is a cascading application, it nicely fits together, while Hive is a thing on its own, kind of. So how would I compare them? I think this one's better.
How do they compare performance-wise?
Performance-wise, can't show you any numbers, to be honest. Sorry, but no. Compliancy is for us more important than performance, I'd say. So we have a big test suite of things that we assert that are running. So we have, we're using a thing called Optique. You might have heard of it. That is the SQL parser in front. And this is a SQL parser for Java. And Optique can do other things as well. It has support for other stuff. But this is what we use on the front end to then turn it into cascading. And that thing actually is meant to be ANSI SQL compliant. So that's our that's the point we're trying to make. Okay, any other questions? Yes?
Are you guys working on some kind of data definition syntax, which is more SQL-like than the old catalog?
Are we working on some sort of data definition language that is more SQL-like than the catalog? Not right now. We are giving this out as is, and we might be building those things in the future. I can't comment on what we're going to build. That being said, it's open source, it's free of charge, it's Apache. Please use it, and we'd like to hear what you do, and maybe we can talk and find something that works for you better. But what we actually envision is that in a big enterprise, the guy that writes a SQL doesn't really do DDL. The DBA does that. So you can imagine that there might be something where you have a bit of a better catalog management tool with user rights and all that stuff. That might be a thing that we do. Yes?
What kind of optimizations are there in the execution time? Does some optimization in the execution time?
What kind of optimizations are there? Well, it can do whatever Cascading can do. Of course, it is more generic code than the Cascading application where you write the operations yourself. But we don't really have performance numbers. We are about to release 1.0 this week. We hope to push the 1.0 out this week. It's release candidate 2 since yesterday, I believe. So we try to push that out. And it's more about the correctness and making it work, and making all the seamless stuff work, and having nice integrations, than being the super fast thing. Because Pig and Hive are more geared towards the early adopters, I'd say. We try to hit where the enterprise sits, where people with SQL knowledge are, that don't want to know about all this back-end stuff that exists. They just want to point their BI tool to files on Hadoop, which we can do, because we have just a normal JDBC driver and it will work. Any other questions? No? Well, thank you very much. Oh, sorry, there's one more question, sorry. Yes?
I wrote it down. Are you integrating, or do you plan to integrate with Yarn and Hadoop 2?
Yarn and Hadoop 2. Are we integrating with Yarn and Hadoop 2? Cascading 2.5, which is currently in WIP builds, has support for Hadoop 2, but not via Yarn, but via Hadoop 2 MapReduce 1, so the compatibility layer. And we're most likely going to skip Yarn completely and move to Tej, Apache Tej, which is in the making. Our bet is that that's going to be better. We hope when it becomes available that's going to be the better bet. If that doesn't turn out so well, we might write Yarn things. That being said, we have, if you go to our homepage, cascading.org, there's a compatibility site where you can see the Hadoop distributions that are compatible with our project. 2.2 has been released a few weeks ago, and it's our partners and Hadoop distributors are right now running our compatibility test, so you can see that. But the Hadoop 2 support will only be in Cascading 2.5, which isn't released yet. So maybe if you take anything away from this session, then go to cascading.org and try to find out what all the good things we have for you in order to make your life easier to write data-driven applications. Thank you very much.